Hello, this is Mrs. Ward, and what I'm going to do in this video is I'm going to cover the remainder of the notes for section 7.1 and 7.2, linear and nonlinear systems of equations, and two variable linear systems. So as we mentioned before, these are the goals for the lesson. We've done the first couple examples, and I'm going to start with example 3 because I don't believe all classes got there. So this one is asking you to solve the systems of equations. So when I look at this, I realize that the first one's linear. The second one is not linear because I have two variables that are squared. So I cannot, when I look at this, I cannot do elimination because I will not be able to eliminate any of my variables because I don't have a variable that's just linear. So because in the second equation, both of them are squared. So I am going to have to do substitution. So if I do substitution, I'm probably going to solve for y in this first equation, and I'm going to say y is equal to x plus 3. I'm going to put this x plus 3 in for the y of this equation. So I'm going to have x squared minus 6x minus 27, and then this will be plus x plus 3 squared is equal to 0. I'm going to FOIL this, so I'm going to have x squared minus 6x minus 27, then this will be plus x squared plus 6x plus 9 is equal to 0. When I look at this, I can see that the negative 6x and the positive 6x will equal 0. Combining like terms, I'm going to have 2x squared, and then negative 27 plus a positive 9 will be minus 18 is equal to 0. I'm going to factor out a 2, and this will be x squared minus 9 is equal to 0. And then this factors is x plus 3, x minus 3 is equal to 0. So I'm going to get x is equal to negative 3 and x is equal to positive 3. So I'm going to have two places where this graph intersects. One is when x is equal to negative 3. The other one was when x is equal to a positive 3. To find the y coordinates, I'm going to take these two and I'm going to substitute them back in to the original equation. I'm probably going to use this equation right here because it's already solved for y, and that would be the easiest to do. So when x is equal to negative 3, I'm going to say y is equal to negative 3 plus 3, and I'm going to have y is equal to 0. So one ordered pair is going to be negative 3, 0. The other one was when x is equal to 3, so y is equal to 3 plus 3, y is equal to 6, so the ordered pair is 3, 6. So when I graph this at negative 3, 0 and 3, 6, I will have points of intersection, and you can graph it to see that. And we'll go over graphing it a little bit later. Number 4, solve a system of nonlinear equations by elimination with no real solution. So I'm kind of telling you that you're not going to have real solutions. So this one, I could do elimination here, and the reason why I can do elimination here and not in the previous one is if I multiply this first equation by negative, that would be a positive x minus y is equal to negative 4. Remember, you have to distribute that negative sign to everything inside that equation. When I do that, the y's will drop out, and I'll be left with x squared plus x is equal to negative 1. And remember, these two are not like terms, that's why I could not combine them. Quadratic, so I'm bringing the 1 over to the other side, so I'm going to have x squared plus x plus 1 is equal to 0. It does not factor, so I might want to check during the quadratic equation. Opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. Remember, my a, my b, and the c in this one is all 1. So it's going to be negative 1 plus or minus the square root. This will be negative 3 over 2. As soon as I see this negative sign underneath the radical, that tells me that there are no real solutions. Since there's no real solutions, that means that these two graphs never intersect. So there are no solutions to that system of equations. And again, you could graph it to see what it looks like. Again, we've talked about graphing a lot, so let's talk about graphing. This is what you learned in Algebra 1. You learned that there's 3 things that can happen when you have linear systems. One is that they could be the same line, which means you would have infinitely many solutions. You could have 2 parallel lines, which means you have no solutions. Or you can have a place where the lines intersect and you have 1 solution. That's what you learned in Algebra 1. Now what we're doing, since we're taking nonlinear equations, and let me get this out of the way. We're now going to have things like this where we can have one solution, we can have two solutions, and we can have zero solutions. So here's your one solution, two solutions, zero solutions. And so with something that's not linear, that gives you more options. Unless it's two linear equations, you can't have like a quadratic and linear and get infinitely many solutions. That's just not going to happen. Um, so if I had this one and I gave you this graph and I asked you to solve by graphing, it's graph for you. They found the points of intersection, so you really don't have to think that hard. You just have to look at the graph. And when I look at this, I have this point here, which is an intersection. And so that point there is going to be 0, 0. And then the other point of intersection I have is here. And that ordered pair will be 2, negative 4. And that would be how I solve this one by graphing, just by looking at the graph, finding the places where they intersect. So this one I have solved the systems equation by graphing. So I'm going to graph them. Let's go to your calculators to graph this. So you're getting out your calculator, and we're going to graph it a little bit differently than you learned how to graph it in Algebra 1. We're going to use a key called the relation key. So when I get out my calculator, so I'm going to add a graphing page, and I am going to plot those two equations. But see how right now, if you look at your calculator, you have this f of 1 of x. That means you're in what's called a function mode on your calculator, which means in order to graph, you have to have it always set equal to x is equal to. That's not going to be convenient when we get to some of these other graphs, so we're going to change this. We're going to hit menu. We're going to go to the graph entry edits, and we're going to pick the button that says relation. So we're going to graph a relation instead of a function. So the first equation was negative 1/2, so I'm going to do control divide, negative 1/2, and then that was x plus y is equal to, and then negative 5/2. Hit enter, and I get my equation. Can move this if I want to. The second one, notice I did not have to solve for y, and that's the advantage of the relation keys. You can just type it in the way you see it. So the next one, I'm going to type in the equation, which is x squared. So x squared plus y squared. And then here's the equal sign. Whoopsie, I got to fix that. Is equal to 25. And let me go over and fix that. And I'm expecting a circle. And there's my circle. Now to look for the place, I see that it intersects here and here. To find the intersection points, I'm going to hit menu, analyze graph, intersection. And what's different about this is since I'm in relation, instead of doing the lower bound and the upper bound like you're used to, it's going to say first corner, second corner. So I'm going to put this dot somewhere, anywhere really. And then second corner, it's going to make this box. See how it's shading in a box? I just have to make sure that that box crosses over the place where they intersect. And so one intersection is going to be negative 3, negative 4. We're going to do that same thing again. Menu, analyze graph, intersection, first corner, highlight over the intersection point, and there's what I have. So those are my 2 points of intersection, is negative 3, negative 4, and 5, 0. And there's my answers, and so I would do negative 3, negative 4, 5, 0. Going on to the next one. This one, it says modeling realized, so from 2008 to 2019, the population city A was increasing at a faster rate than the population city B. The models approximate the two populations in thousands are, and it gives you these two things. Just pointing out a few points here. So in 2008, that's going to be our time 0. So this is 2008. So the population of this city in 2008 was 9,000, or was it 4,947. The population city 2 in 2008 was 5,118. This 95T tells you that each year you're increasing your population by 95 people. And then city 2, each year you're increasing your population by 41.4. You can solve this system. I probably wouldn't even graph. I would probably do the easiest way, because the way it's set up is I would probably do elimination and multiply one of these by a negative number, a -1. So let's say I just multiply the second one by -1. So copying down the first equation, because I like to have them together, 4,947.3. And then copying down this one, when I multiply it by negative, I'm going to have negative P is equal to negative 5,118 minus 41.4T. Now when I add those two, the P's will equal 0, and then I'm going to add these two. And again, negative 170.7, and then this will be plus, so 95. And then this will be 53.6T. I'm going to bring this over since it's linear, so I'm going to have 170.7 is equal to 53.6T. So I'm going to divide the 170 by the 53.6, and I'm going to get T is equal to 3.18 if I round to 2 decimal places. I'm going back and reading the question. It doesn't ask a question. Well, let me tell you. So this is time in years. So in approximately 3 years, the populations will be the same. And then if I wanted to find out what that population would be, is I would put in that 3.18. So I'm going to put it into the one equation. So I'm going to put it into, let's say I put it into here. And so I'm going to say population is equal to 5,118. Actually, I'm doing the one above. Plus 41.4 times 3. And I'm just going to use the 3 because this is going to be an estimation because I rounded it to 3 years. And I'm going to have a population of approximately 5,242 people. Again, that's approximate because you can't have a 0.4 person, and you can't have, but it's going to take a little over 3 years for those two cities to have the same population. Okay, method of elimination we've already talked about. Solved by elimination. So these ones that we've done so far, we've only had to multiply one equation. Just to review, sometimes you have to do elimination, you're going to have to multiply both equations by something. So when I look at this, I'm looking at 3x plus 11y and negative 2x minus 5y. I want a number that both coefficients will go into. I probably want the lowest one possible. So I'm probably going to choose to eliminate the x, and I'm probably going to think that the lowest common multiple of those two is going to be 6. So I'm probably going to multiply this one by 2. And when I do that, I'm going to have 6x plus 22y is equal to 8. I'm going to multiply the second equation by a positive 3. That way they'll be opposites. And I really do want these to be opposites, and I don't want to have to think about subtracting. So this will be minus 15y is equal to 27. When I add those two equations, I get the x's are eliminated, they're 0, so I'm going to have 7y is equal to 35. Divide both sides by 7, y is equal to 5. Substituting into either one of the first equations, so I'm going to say 3x plus 11 times 5 is equal to 4. So I'm going to 3x plus 55 is equal to 4. 3x is equal to 51. X is equal to 17. So my ordered pair solution is 17, 5. That one I had to multiply both equations to get something to eliminate. And I chose to eliminate x. You can choose to eliminate y, and that would have been fine. I would have multiplied this one by 5 and this one by 11. Then when you solved, you would have gotten 17 first, and then you'd substitute back in to find the 5. I solve the system by elimination. So this one, when I solve, I'm choosing which variable to eliminate. Let's say I eliminate the y just to do something different. The lowest number that both 6 and 9 will go into is 18. So I'm going to multiply this top one by a positive 3. If I do that, that's negative 12x plus 18y is equal to 36. I'm going to multiply the lower one. I'm going to choose to multiply by a negative 2. That way this will be a negative 18. That's kind of what I want. So this will be positive 12x minus 18y is equal to negative 36. When I add these two, I think you know what's coming. When I add these two, the x is equal 0, the y is equal 0, and this side equals 0. So you're basically left with 0 is equal to 0. Since this is a true statement, that means that these two lines are the same line. They're just multiples of each other. So you're going to have infinitely many solutions. You cannot use an interval notation, say negative infinity to positive infinity, because the infinitely many solutions mean that they have to meet the requirements that both those points are on that line. So it's infinitely many solutions. That happens when you get 0 is equal to 0. If I would have done all this work and I would have gotten something like 16 is equal to 0 when I did all my work, and that's not true, then there are no solutions. And that's how you tell the difference algebraically, whether you have infinitely many solutions or no solutions. Okay, you have an airplane flying in headwinds traveling at 1,650 miles between two cities in 3 hours and 18 minutes. On the return flight, the distance is traveled in 3 hours. Find the airspeed of the plane and the speed of the wind, assuming that both remain constant. So word problems, everyone's favorite. I like to do distance is equal to rate times time. I like to make boxes. It makes me happy. So I'm going to make a box. And I'm going to say that this is 2, distance between. So this is going. So this is 2, and this is a return. And there's my distance. There's my rate, and there's my time. Distance, rate, time. It says the distance is 1,650, and that would be true for both of 2 going there and coming back. The mileage isn't going to change. Going there, they can travel in 3 hours, 18 minutes. So 3 hours, 18 minutes. I have to change that to just hours. So I'm going to have to change that 18 minutes into a fractional part of an hour. So to do that, I would take 18 and divide it by 60, and I get 0.3. So this is 3.3 hours. So that's my time going there. My time on the way back is only 3 hours, which means the wind is helping me. It says find the airspeed of the plane and the wind, assuming that both remain constant. So this one is going to be the speed of the plane minus the wind. And the reason why I'm subtracting the wind is because obviously the wind must be working against the plane because it's taking me longer to get there. This will be the plane plus the wind, because obviously the wind must be helping the plane, so it's making it go faster, so it's going to add to the speed of the plane. I'm going to set up 2 equations based on my table. My first equation is going to be 1,650 is equal to my rate, which is P minus W, times my time, which is 3.3. My second, that's based on this table equation right here. My second one is based on this one, so I'm going to say 1,650 is equal to P plus W times 3. So now, in order to solve this, well, I know how I want to do it, but that's probably not the way you're going to think to do it. So I am going to multiply 3.3 times both of these. So I'm going to have 1650 is equal to 3.3p minus 3.3w. And then over here, the other one, I'm going to distribute my 3 and have 1650 is equal to 3p plus 3w. Now, in order to solve, I'm probably going to solve by, I don't know, do you want to do substitution or do you want to do elimination? Well, you're not here to tell me, so I guess I will do, let's do substitution. We haven't done that in a while. So I'm going to solve for p in this equation without the decimal. So let's say I solve for this p right here. So I'm going to have 1650 minus 3w is equal to 3p. I'm going to divide everything by 3. And when I do that, I'm going to have 550 550 minus w is equal to p. So I'm going to put this back in for this p here. So when I do that, I'm going to have 1650 is equal to 3.3 times p, which I just said was 550 minus w, and then that's going to be minus 3.3w. So 1650 is equal to, and then 3.3 times 550 is equal to 1815 minus 3.3 minus, w, minus 3.3w. So now I'm going to take 1650, subtract that 1850, and get negative 165 is equal to negative 6.6w. Divide, and I get w is equal to 25. So that's going to be 25 miles per hour. That is the speed of the wind. So now to find the speed of the plane, I'm going to put back in probably here, right? So I'm going to say 550 minus 25 is equal to p. So p is equal to 525. So the plane is going 525 miles per hour, and the wind is going 25 miles per hour. And that's how you do it. I think tables are key. The last one is not on your note sheet. It's a bonus one. It's one I thought, oh, I better add. So this one I have a supply and demand, and I want to find what's called the equilibrium, which means the place where the supply and the demand curves equal each other, and that's known as the place where you want to be in business. That's where you want to set your price and how many units you want to make. So in order to do this, I am going to graph both of these equations. Since both of these equations are set equal to P, and P stands for price, I'm probably, when I go back to my calculator, I'm going to clear all this, actions. Where is that? Hold on, hold the presses. Okay, get out of there. So I'm going to start a new page then. Let's just start a new page because obviously this isn't working for me. So let's go to a new page. So I'm going to add another graph page. It's in functions, and I'm okay leaving it in functions because both of these are set equal to P. So the first equation is 81 minus 0.55x. Enter. Whoops, can't see it. The second one is going to be, I think just, 0.125x. So I have that one, so I'm going to hit menu. Mrs. Pesic would not like me right now. I'm going to go look for that other equation, so I just zoomed out a couple times. So here's this. There's this. I'm going to find the place where they intersect. Menu, analyze graph, intersection. This one, because it's a function, does the lower bound, upper bound, and it gives me 120.15. So let's grab this and put this on the other page. So that puts that there. And what does that 120.15 mean? Remember, the X was the number of units. So in this case, I'm going to have to sell this is 120.15. This is my X. This is my P. So the X is the number of units. So I'm going to sell 120 units or make 120 units, depending on how you look at it. And the price will be $15 is the price. And that's what's called the equilibrium point. That's the place where the two graphs intersect. That's where your supply and demand meet each other. Okay, and then here's your homework. I know it's a lot, but they're easy. So best of luck, and I will see you next time in class.